Okay, in the last video, I did not talk about the special identities, the really important one, Pythagorean theorem, so that's what I'll go over now. So I apologize for that. All right, so you've probably been working on Pythagorean theorem or been at least introduced to it since about 5th grade. And what Pythagorean theorem says is if you have a right triangle, then the legs of the triangle, if you square a squared plus b squared, the sum of those squares will equal the square of the hypotenuse. Well, now that brings us to trig. So notice that if you have a right triangle, and I've set that on the first quadrant, and notice the theta is right here, and this side over here is the opposite side. Remember what I told you on the xy coordinate? Y also represents the opposite and the sine value, and x represents the adjacent and the cosine value. Well, it also is the a and the b. So if a squared plus b squared equals c squared, then cosine squared plus sine squared, doesn't equal e. It equals 1. So on the unit circle, when each radius is 1, when each hypotenuse or each radius of the unit circle is 1, then usually we write the sine value first, or that's how I normally am used to it. So it's sine, I left off the theta. Without the theta, we don't have trig. So sine squared, and you can write it that way without that parentheses, plus cosine squared theta is equal to 1. All right, so that is a Pythagorean theorem. Then there is kind of two twists to that, so I'll call that theorem number 1. Well, theorem number 2 is tangent squared theta plus 1 is equal to secant squared theta. But all this is, it's this right here, but just rewritten with different values. So tangent squared means, remember, is the same as sine squared over cosine squared. Well, if we're going to add these two things together, they need to have the same denominator. So 1 we could write as cosine squared theta over cosine squared theta. Well, now these two share the same denominator, so that's cosine squared theta. And then sine squared plus cosine squared, well, what does that equal? It equals 1. And remember in the last video, the reciprocal identity, secant theta is 1 over cosine theta. Well, if secant is squared, cosine will be squared. So this 1 over cosine squared theta does in fact equal secant squared. So this tangent squared plus 1 is equal to secant squared is just a variation of sine squared plus cosine squared equals 1. All right, well then there's one other variation. Get this stuff out of the way now. And the other variation is using cotangent. So cotangent theta plus 1 is cosecant squared theta. And it's very similar. Remember, cotangent is cosine squared over sine squared. Because this is squared, those are both squared. And then this will be sine squared theta over sine squared theta, because that's just 1. Well, then when you add cosine squared plus sine squared, then you have 1 over sine squared. Well, 1 over sine squared is the reciprocal. The reciprocal of that is cosecant squared. So those three Pythagorean theorems are just the same version of each other, and they're all the version of a squared plus b squared is equal to c squared. All right, that's it for this one.